Welcome back to my YouTube channel. This video is on matrix method and examples related to matrix method. In the matrix method, we are writing the given system of equations in the form Ax equal to B, where A is a coefficient matrix. It is obtained by writing the coefficients of x, y, z from the three equations. X is a matrix of unknown and B is a constant matrix. So after writing the given system of equations in the matrix form Ax equal to B, we are calculating determinant of A. If determinant of A is 0, then given matrix is said to be singular and its inverse does not exist. Point to remember. If determinant of A is equal to 0, then matrix is said to be singular and its inverse does not exist. If determinant of A is not equal to 0, then the matrix is said to be non-singular and its inverse exists. So after this we are going for inverse of the matrix, or we are finding A inverse. So A inverse is obtained by taking the formula 1 divided by determinant of A into adjoint of A. So adjoint of A is the transpose of cofactor matrix. By taking transpose of cofactor matrix, you will get adjoint of A. Afterwards, we are substituting the value of adjoint of A in the formula A inverse is equal to 1 divided by determinant of A into adjoint of A. After that, we are taking the value of A inverse in the formula x equal to A inverse B and calculating the values of x, y, z by using matrix multiplication. So this is called the matrix method. So now we are having one example on matrix method. So this is very important. 45th question. See, question number 45th will come on matrix method for your March 2024 annual exam, and it is for 5 marks. Example: solve the system of linear equations. Solve the system of linear equations by matrix method. By matrix method. 2x minus 3y plus 5z is equal to 11. This is the first equation. Second one is 3x plus 2y minus 4z is equal to minus 5. And x plus y minus 2z is equal to minus 3. It is in the model question paper 2024. I repeat question once again. Solve the system of linear equations by matrix method. 2x minus 3y plus 5z equal to 11. Next one is 3x plus 2y minus 4z equal to minus 5 and x plus y minus 2z equal to minus 3. So these are given system of equations. So I will write solution. So I will write given equations once again as it is. So I will write given. See, given system of equations we are having 2x minus 3y plus 5z is equal to 11. 3x plus 2y minus 4z is equal to minus 5. And third equation we are having x plus y minus 2z equal to minus 3. So these are given system of equations. For this I call equation number 1. Now I will write these system of equations in the matrix for Ax equal to B. So I will write one sentence. The above system of equations, the above system of equations the above system of equations can be written can be written in the matrix form, Ax is equal to B. So see, this system of equations I am writing in the matrix form Ax equal to B. Here A is a coefficient matrix obtained by taking the coefficients of x, y, z for first, second and third equations. See once again, A is the coefficient matrix obtained by writing the coefficients of x, y, z for these three equations. Next, x is a matrix of unknown. X is what? Matrix of unknown, and its values are x, y, z in a column, in one column, and we are having three rows. B is a matrix of constant. So B is called a constant matrix. So I will write here where A is equal to, I will write, say the value of A. So I will write 2 minus 3, 5. It is in first row. 2 minus 3, 5 are the coefficients of x, y, z, and these 2 minus 3, 5 which are taken for the first equation. Next, yes, in second equation we are having the coefficients of x, y, z are 3, 2, minus 4. 3, 2, minus 4. And it should be written in second row. Next, we are having third equation is x plus y minus 2z. So here nothing in front of x. And always you think, or always you consider there is a 1 in front of x. So I will write 1 here. Next, here we are having a plus 1. And here the coefficient of z is minus 2. So this is A matrix. Next, yes, unknown you write. X is nothing but matrix of unknown, and its values are x, y, z. After that, B we are having. So B is a constant matrix, and which is obtained by taking the constant which are on the right side of the equation. So we are having L1 minus 5 and minus 3 are the constants which are on right side. So I will take the value of B is equal to L1 minus 5, and next one is minus 3. L1 minus 5 minus 3. So this is A, this one is x unknown, and this is the constant matrix. So now we go for determinant of A. So I will write one sentence to find determinant of A. So calculate determinant of AU. So therefore I will write determinant of A is equal to. So I calculate determinant of A. See, while calculating determinant of A, you write a plus minus plus. So very simple. While calculating determinant of A, expand it along the first row. Expand it along the first row. So first you write symbols for this first row as plus, minus, plus. So first you take plus 2 outside. Plus 2 outside. After that you delete this row and this column. So plus 2 right, delete this row and this column. Remaining elements you have to take inside the determinant. So plus 2, first you keep outside. This plus 2 you keep outside, and remaining elements you have to write inside the determinant by deleting this first row and first column. So I will write plus 2 outside. Next 2 minus 4. 2 minus 4, 1 minus 2 will come. 1 minus 2 will come. Next, you multiply these two. Minus into minus plus. So minus into minus is plus. You write plus 3 here. Next, yes, take the values inside the determinant by deleting this row and this column. So why I am deleting this row and this column is because this 3. This minus 3 is present in the first row and second column, right? So that's why I am deleting this row and this column. So elements will get 3 minus 4, will get 3 minus 4, 1 minus 2, 1 minus 2. Next, you write a plus 5, you write a plus 5 and take the elements. Take the elements inside the determinant by deleting this row and this column. Delete this row and this column. So I'll get elements inside the determinant are 3, 2, yes, 1, 1. See, while finding the determinant of A, you first take a plus 2 outside into minor of 2 you take, plus 2 right outside, minor of 2 you take. So minor of 2 is obtained by deleting this row and this column. Next minus into minus plus, you must write minus symbol here. So you multiply these two, minus into minus plus. So 3 you keep outside. After that you take minor of 3. So minor of 3 is obtained by deleting this row and this column. So inside the determinant you will get 3 minus 4, 1 minus 2. After that you write plus 5. Plus 5 you write. So into you take minor of 5. So minor of 5 is obtained by deleting this row and this column. So yes, 3 to 1 1 will come inside the determinant. So already we are having plus minus plus symbol. Right, so plus are written, plus here are written. Next one we are having minus into minus plus, and here one is plus 5. So these symbols are we using when expanding the matrix along the first row. When you finding determinant of A along the first row, at that time you write plus minus plus. When expanding the determinant along the second row, at that time you write here minus plus minus. This is very important. See, once again I will repeat. When you expanding this matrix while finding determinant of A, you write symbols here plus minus plus. And when you finding the determinant of A by expanding it along the second row, at that time you write symbols minus plus minus. When you finding the value of determinant of A, expanding it along the third row, at that time you write symbols plus minus plus. Alright, so this is the very important. These things you remember. So therefore I will write determinant of A is equal to plus 2 write as it is. Next to go for further simplification. So see, 2 into 2 minus 2. 2 into minus 2 is minus 4. Very important. So we are having, yes, it is 2 outside, 2 into minus 2. So 2 outside, 2 into minus 2. 2 into minus 2 is minus 4. Next minus will come. You already know how to evaluate the determinant del is equal to A, B, C, D, which is having the order 2. So you are multiplying these elements first. That is equal to A into D is 80. Minus you are taking product of these two. That is product of B and C, you are taking BC. So you already seen this type of examples or this form. So this form we are using here. So del equal to AD minus BC. Yes, this example, this general form we are using here while finding determinant of this one, which is having the order 2. So see, 2 into minus 2 minus 4. Next 1 into minus 4. 1 into minus 4 is yes, minus 4. Bracket complete. Next you write plus 3. Plus 3 you write. So inside the square bracket you write 3 to the minus 6. Minus you write minus 4 into 1. Minus 4 into 1 is minus 4. Next plus 5 you write. Plus 5 you write 3 1s are 3. 3 1s are 3. Next 1 to the yes 2 it is minus 2. Right? So now this is equal to I will write plus 2. Minus 4 you write as it is. Minus into minus plus 4. Plus 3 you write. Next one minus 6 you write. Minus into minus it is plus 4. Plus 4. Plus 5 you write. 3 minus 2 it is 1. So 3 minus 2 you are having 1. So now this is equal to 2. Minus 4 plus 4 0. Plus I will write 3. Minus 6 plus 4. So minus 6 plus 4 is minus 2 right. Minus 2. And after that we are having plus 5 into 1 is 5. 5 into 1 is 5. So now 2 zeros are 0. 3 into minus 2 minus 6 plus 5. So E is equal to minus 6 plus 5. It is minus 1. See, we are having a minus 6 plus 5 is minus 1. This is the value of determinant of A. So therefore I will write. determinant of A is equal to determinant of A is equal to determinant of A is equal to minus 1. This minus 1 is other than 0. See, determinant of A we are having minus 1. It is not equal to 0. Therefore, the coefficient matrix is non-singular and hence its inverse exists. So therefore I will write as one sentence, hence its inverse exists. Its inverse exists. Now after this you go for to find A inverse. You go for inverse of the matrix. Calculate inverse of the matrix. So inverse of the matrix is calculated by using the formula A inverse is equal to 1 divided by determinant of A into you write adjoint of A. So this is the formula of A inverse, very important, you remember. I will put star mark for this. See, A inverse is equal to 1 divided by determinant of A into adjoint of A. So now see adjoint of A. So determinant of A already we have minus 1 and now it is required to find adjoint of A. So therefore adjoint of A is obtained by taking a transpose of the cofactor matrix. So we first find a cofactor matrix. So therefore I go for cofactor of matrix. So I call this is the equation number yes, we call 1. Roman letter 1 is 1. Roman letter 1 is 1. So we call as a number, that is as English number 1. So therefore I go for cofactor of the matrix C. So I go for cofactor of the matrix A. Cofactor of the matrix A is equal to. So if I am finding cofactor of the matrix A, I will give as one clue for you. So this is very simple. So first have to write one big matrix, that is big these as matrix symbol you have to write. Matrix symbol you write. So now as plus you write and keep the symbol determinant inside this big matrix. So plus you write and keep symbol of determinant. Next you write minus, keep the symbol of determinant. After that you write plus, keep the symbol of determinant. Right? Next you write minus, keep the symbol of determinant. After that you write plus, keep the symbol of determinant. Next you write minus, keep the symbol of determinant. So this is very important. Right? Next you write plus, keep the symbol of yes, determinant. Next you write minus, keep the symbol of determinant. And after that you write plus, keep the symbol of determinant. So why here I am writing plus minus plus minus plus minus plus minus plus means because while finding cofactor of the matrix A, cofactor of the matrix A, we are finding a cofactor of each and every element. So cofactor of each and every element is obtained by multiplying the determinant obtained by deleting row and column where the element is present, where the element which is present in the matrix by minus 1 raised to I plus j, minus 1 raised to I plus j. So I means it is a ith row of the element A and jth column of the element A. So ij is a ith row and jth column of the element A. Right? So now see, we are having the coefficient matrix. Already we have coefficient matrix. So see, pause the video and see back the coefficient matrix. So I will write once again here coefficient matrix. So side I will write coefficient matrix we are having. See, The coefficient matrix is 0, 6, 7 minus 6. Sorry. So see, coefficient matrix is we are having. So coefficient matrix is S2 minus 3. Coefficient matrix is 2 minus 3 it is. The next one is 5 and 3, 2 minus 4. Yes, 1 minus 2. So this is what coefficient matrix. Pause the video and see back the value of P is correct or not. See, it is coefficient matrix. Its values are 2 minus 3, 5, 3, 2 minus 4 and 1, 1 minus 2. So now see, I am finding the cofactor of this. I am finding the cofactor of this A. So now see, first you find cofactor of 2. So while finding cofactor of 2, yes, first you write a plus symbol. So why it is plus means because it is minus 1 raised to I plus j. But this 2 is lies in first row and first column. See, 2 lies in first row and first column. So hence you get minus 1 raised to 1 plus 1. So minus 1 raised to 1 plus 1 means it is minus 1 square. So minus 1 square is nothing but plus 1. And simply I return plus symbol. So now take the elements inside the determinant obtained by deleting this row and this column. Because we are finding this cofactor of 2. We are finding the cofactor of 2. The cofactor of this 2 is obtained by multiplying the determinant obtained by deleting this row and this column by minus 1 raised to I plus j. Or simply I return S plus symbol. Now you delete this row and this column. Remaining elements you take inside the determinant. So you will get 2 minus 4. Next you will get 1 minus 2. So delete this row and this column. So you will get elements inside the determinant are 2 minus 4, 1 minus 2. Next you write minus symbol. Minus symbol already we have, right? So why it is minus means we are taking minus 1 raised to I plus j. So this minus 3 is in where? Minus 3 is in yes, first row and second column. It is in first row and second column. So hence you get minus 1 raised to 1 plus 2. Minus 1 raised to 1 plus 2. So minus 1 raised to 1 plus 2 means we are having minus 1 cube. So minus 1 cube is minus 1 and simply I return minus symbol. So see, cofactor of minus 3 you are finding. Cofactor of minus 3 you are finding. So delete this row and this column. Delete this row and this column. Remaining elements you take inside the determinant. So you will get here 3 minus 4. 3 minus 4. Next you will get 1 minus 2. 1 minus 2. Next cofactor of 5 you will find. Cofactor of 5 you will find. So cofactor of 5 is obtained by deleting this row and this column, multiplying the determinant obtained by deleting this row and this column by minus 1 raised to I plus j. So minus 1 raised to I plus j means this 5 is in the first row and third column. So hence you get 1 minus 1 raised to 1 plus 3. So minus 1 raised to 1 plus 3 means it is minus 1 raised to 4 and its value is yes, plus 1. So simply I return plus symbol. Next elements you take inside the determinant obtained by deleting this row and this column. So you will get 3 to 1 1. So here you will get a 3 to 1 1. Next you find cofactor of 3. So cofactor of 3 you find, already I return minus sign. Delete this row and this column. Delete this row and this column. So you will get a minus 3 5 minus 3 5 1 minus 2. 1 minus 2. Next you take a cofactor of this 2. Already we are having plus symbol. Delete this row and this column. So cofactor of 2 we are taking, delete this row and this column. So you will get 2 5 1 minus 2. 2 5 1 minus 2. Correct value right. So very easy simplification. Correct value you write. Next you go for cofactor of minus 4. So already we have minus symbol here. Next one you delete this row and this column. Delete this row and this column. So you will get 2 minus 3 1 1. So you will get 2 minus 3 yes 1 1. Next one, cofactor of 1 you go. Already we have plus symbol. Delete this row and this column. Delete this row and this column. So remaining elements you take inside the determinant minus 3 5 2 minus 4. Next one, cofactor of 1 you find. Delete this row and this column. So delete this row and this column. See, moment of my hand, delete this row and this column. So it is a 2 5. Next 3 minus 4 will come. 3 minus 4 will come inside the determinant. Next cofactor of this minus 2 find. So already we are having plus symbol. Next cofactor of this minus 2 find by deleting this row and this column. Remaining elements you have to write inside the determinant. Delete this row and this column. So elements will come here 2 minus 3, 2 minus 3 and 3 2. 2 minus 3, 3 2. So this is the very important. Correct value you write. So now see after this. So I go for calculation. I go for further calculation. So see, therefore I will write a cofactor of matrix A is equal to cofactor of matrix A is equal to, see, you are having 2 into 2, 2 into minus 2 minus 4 minus 4. See, 2 into minus 2 minus 4. Next minus will come in between. In between minus will come. Next 1 into minus 4, it is minus 4. So now minus 4 minus of minus 4, minus 4 minus of minus 4, it is plus 4. Minus 4 plus 4, its value 0. So 0 will come here. Next you write this minus symbol. 3 into minus 2 is minus 6. 3 into minus 2 is minus 6 will come. Next yes minus, see, yes, you keep minus sign as it is. Keep minus sign as it is. 3 into minus 2 minus 6. Next minus 1 will come. Minus will come. Minus 4 into 1 minus 4. So see, minus to the minus plus 4. Plus 4 minus 6 minus 2. Minus 2 this minus. Very important. So minus to the minus plus 4. Plus 4 minus 6 minus 2. Minus 2 this minus. It is the plus 2. Plus 2. Next one. Yes, 3 1s are 3. 1 2s are minus 2. So 3 minus 2, its value is 1. Its value is 1. Next, yes, go for this one. Minus 2 right as it is. Minus 3 into minus 2, it is plus 6. See, minus 2 to minus plus 3 to the 6. Next, 1 5 is minus 5. Minus will come in between the two numbers. Next, 6 minus 5 is 1. 1 minus, it is minus 1. So write minus 1 here. Minus 1 here. Plus you write as it is 2 into minus 2 minus 4. Next minus 1 5 is 5. So minus 4 minus 5, it is minus 9. So here you write minus 9. Next minus you write 2 1s are 2 you write. Minus you write 2 1s are 2 you write. Next one 1 into minus 3. 1 into minus 3. So 1 into minus 3 is minus 3. Clear? See, minus symbol you write as it is 2 1s are 2. 1 into minus 3 minus 3. And in between these two numbers minus will come. So now see, we are having yes minus into minus plus. Minus into minus is plus, plus 3, plus 2 5 and symbol minus. So minus plus is minus and here you write minus 5. Minus 5 you write. Next see, plus symbol you write as it is. Plus symbol you write as it is. Minus 3 into minus 4, it is 12. 3 4s are 12. 2 5s are minus 10. So see, 12 minus 10 is 2. So you write a plus 2 here. Plus 2 you write. Next minus you write. Next one you write minus. Minus you write. Yes, 2 into minus 4 minus 8. So multiplying these two elements. 2 into minus 4 minus 8 minus 5 3s are 15. 5 3s are 15. So see, we are having minus 15 minus 8. Minus 15 minus 8 minus 23. Minus 23 is minus symbol. It is a plus 23. Plus 23. Very important. Next plus you write. 2 to the 4 you write. Minus you write. Next 3 into minus 3. 3 into minus 3 is minus 9 you write. Minus 9 you write. See, once again 2 to the 4 and minus will come. Next minus 3 into 3 minus 9. Minus into 9. Minus into minus 9 plus 9 plus 9 4 13. 13 plus 13 it is. So this is a cofactor of matrix A. So correct simplification you do. The simplification of numbers is very important here. Next, after getting cofactor of matrix A, you go for adjoint of A. So see, adjoint of A is equal to transpose of cofactor matrix. Transpose of cofactor matrix. Cofactor of matrix. So transpose of cofactor matrix is obtained by interchanging rows and columns of this matrix. So this is cofactor matrix. And adjoint of is obtained by taking the transpose of this. And the transpose of this matrix is obtained by interchanging rows and columns. So transpose of the matrix A is equal to, right? So first you write 0 to 1. So it is row, you turn back into in column. So see, it is in row, you turn it in the column. So 0 to 1 will come. Next minus 1, minus 9, minus 5 will come. Next 2, 23, 13 will come. So row into column you write. So this is what adjoint of A. This is adjoint of A. Right? So now, yes, you substitute this values in the formula A inverse is equal to 1 divided by determinant of A into adjoint of A. You substitute this values in the formula A inverse is equal to 1 divided by determinant of A into adjoint of A. In that formula, you have to substitute. So therefore, I will write yes, A inverse is equal to, see, we are having A inverse is equal to 1 divided by determinant of A. Already we have determinant of A. Pause the video and see back. The value of determinant of A is minus 1. It is calculated. It is calculated at the beginning. So determinant of A is minus 1. Next to take adjoint of A. So adjoint of A, this one you write here. So adjoint of A, you are having a 0, minus 1, 2, minus 9, 23. And next one, 1 minus 5, 13. 1 minus 5, 13. So you know 1 by minus 1 is minus 1. Now you multiply by minus 1 to the all the elements of the matrix. 1 by minus 1 is minus 1. Multiply minus 1 to the all the elements of the matrix. So therefore I will write A inverse. So therefore A inverse is equal to, see, 1 by minus 1 into 0, it is the 0. Next one, 1 by minus 1 is minus 1 into minus 1 plus 1. Plus 1 it is. We are having plus 1. Next, yes, after this, see, we are having 1 by minus 1 is minus 1 into 2, it is a minus 2. It is a minus 2. Minus 2. 1 by minus 1, minus 1 into 2, minus 2. 1 by minus 1, minus 1 into minus 9, it is plus 9. Minus 1 into 23, minus 23. Minus 23. Minus 1 into 1, minus 1. Minus 1 into minus 5, minus 1 into minus 5, it is a plus 5. Minus 1 into 13, it is a minus 13. So this is what A inverse. So now after this we are having the formula x equal to A inverse B. So substitute the values of x, A inverse and B in this formula. So therefore x means what it is, x y z. X means x y z is equal to A inverse. So write A inverse is 0, 1, minus 2, minus 2, 9, minus 23. And next I'll write minus 1, 5, minus 13. Next into B. So B means we are having a constant matrix. B means it is constant matrix and its values are L1 minus 5 minus 3. Yes. Now I want to find the values of x, y, z. So therefore I will write this unknown matrix as it is. Now I go for row into column multiplication. You know matrix multiplication in last video. So row into column multiplication. You already seen a matrix multiplication in last video. That method you have to follow here. So see, first row into this column I go. 0 into L1, 0. Next 1 into minus 5 is minus 5. Minus 2 into minus 3, it is plus 6. So very important. The first row into this column is over. Next you go for second row into this column. Minus 2 into 11 minus 22. 9 into minus 5 minus 45. Minus 23 into minus 3. See, minus 23 into minus 3. Minus into minus plus 23 3 are 69. Remember the table. Next one. Minus 1 into 11. Minus 1 into 11 is minus 11. Next 5 into minus 5 minus 25. Minus into minus plus 13 3 is 39 it is. 13 3 39. 13 3 39. So now I go for further simplification. So therefore I'll write x y z is equal to see, we are having 0 minus 5 plus 6 minus 5 plus 6 1 minus 22 minus 45 minus 67 plus 69 it is 2 minus 11 minus 25 it is a minus 36 plus 39 it is 3. So very simple values are coming. So its order we are having 3 rows 1 columns. Its order is also 3 rows 1 column. So see, order of both the matrices are same here, and in between these two matrices are in between these two matrices we are having equal to symbol. So order also equal, hence their corresponding elements are also equal. We are having property of multiplication. If both the matrices are having the same order, then their corresponding elements are equal. That is the equality of matrices. So therefore I will write x equal to 1, see x equal to 1, y equal to 2 and z equal to 3. So these are required values of x, y, z or required values of variables. So now after getting the values of variables, we do verification. You identify whether obtained values of x, y, z are correct or not. So go for verification. So I will write here to verify or to check. To verify or to check. So while checking or while doing verification, you take LHS of equation 1. So LHS of 1 you take. So LHS of 1 we are having. LHS of the equation is 2x minus 3y plus 5z. Alright. So here substitute the values of x equal to 1, y equal to z equal to 3. So you'll get 2 into 1 minus 3 into 2 and plus 5 into 3. So now 2 1s are 2 minus 3 2s are 6 5 3s are 15. So see, 15 plus 2 17 minus 6 is 11. So this is equal to RHS. So 11 is in RHS in the given system of equations. So likewise you take LHS of equation 2, substitute the values of x, y, z, see whether you are getting RHS or not. And yes, in third also you take x, y, z in the LHS of equation and see whether you get RHS or not. In all the three equations, if you get LHS equal to RHS, then our values of x, y, z are correct. If any one fails, if in any one you don't get LHS equal to RHS, then the values of x, y, z are wrong, or otherwise there will be something mistakes in your simplification, right? So that's why you do correct simplification. So nothing is here. The first you find determinant of A. After getting determinant of A, go for cofactor of matrix A. So by taking transpose of cofactor matrix of A, you will get adjoint of A. Substitute the value of adjoint of A in the formula A inverse. So A inverse equal to 1 divided by determinant of A into adjoint of A. After that you take the value of A inverse in the formula x equal to A inverse B and do matrix multiplication. So you will get the values of x, y, z. A very simple example it is. So you try another 4 to 5 examples which is in textbook. The same method will repeat. So method is same but slightly different in the coefficients of x, y, z. So that is the only difference. There is nothing change in the method. So method will come as it is, right? So this is for 5 marks and they will ask 45th questions on this. So fixed question will come on this. So only change in coefficients, right? So you are given maximum support for me, and in next video I will tell integration. So some important concepts which are related to integrations and some problems on applications of integration. So you are given maximum support for me. For that, I thank you, and subscribe my channel. Thank you for watching.